Subscribe our channel, press the bell icon for latest videos.
Hi friends, here in this video we are going to see the concept of thermal stresses and strain. So let's get started. First I'll draw the diagram. Now suppose if there is a bar or a rod having length L, initially the temperature is T1, and when this bar is heated by supplying an external heat, this bar is having a coefficient of thermal expansion denoted by alpha. So when it has alpha value, it is going to get expand when it gets heated, that is when the temperature rises. And here I am showing the free expansion of this bar. So when this bar is heated, it is going to expand freely only up to this length. So when it is expanding freely, in that case no stresses would be induced in the material. I am repeating the point that when it is heated and it is expanding freely, that is we are not stopping the expansion, at that instant there won't be any stress inside the material. But the moment we have a restriction over here, just for an example I am showing here, if we are stopping the free expansion, so this much is the amount which is the expansion prevented, and because of this barrier or the expansion prevented, now there will be stress produced inside the section, and such kind of stresses which are there because of the temperature are called as temperature stresses. Initially the temperature of the rod is T1, after heating it reaches another state and then the temperature becomes T2. So first I'll write the formula for free expansion. It is denoted by delta L, also called as the deflection, that is given by alpha into delta T into L. Unit is mm, where alpha is coefficient the coefficient of thermal expansion or thermal contraction, and depending upon the value of alpha will decide, that is the material will respond to change in temperature quickly or slowly, because if the value of alpha is greater, it means the material is more sensitive to temperature difference and it will expand or contract freely more rapidly when alpha value is higher. But if alpha value is lower, it means that material will expand or contract slowly, and it is having a unit of per degree Celsius. Delta T is change in temperature for the rod. That change in temperature is final temperature minus the initial temperature. Unit is degree Celsius, and L is the length of this bar. Then after free expansion, I'll write down thermal strain or temperature strain. Thermal strain, like in longitudinal strain, it is denoted by small e, and that is given by change in length upon original length. So change in length is this deflection, which is alpha into delta T into L divided by L. From the numerator and denominator, L gets cancelled out. So strain is alpha into delta T, which is called as the thermal strain or temperature strain, and it has no units. Then similarly thermal stress. Now since from Hooke's law stress is directly proportional to strain within the elastic limit. So therefore stress is equal to strain into Young's modulus, which is the constant of proportionality, and therefore stress is strain into Young's modulus, or Young's modulus is stress upon strain. So in order to get thermal stress, I'll say that since stress is equal to strain into Young's modulus, therefore the thermal strain is alpha into delta T. So this is the formula for thermal stress or temperature stress. The example which I had taken here was for heating. Similarly, we can consider the example for cooling as well. That is, when the rod temperature decreases, at that time it would be a free compression. It would be free contraction or free compression due to decrease in temperature. And to avoid that, if we are allowing, for example, the free contraction to take place because of low temperature, then there won't be any stress. But the moment we are avoiding that contraction by pulling the rod, then it would result in a thermal stress for a member which is subjected to low temperature. So that was regarding thermal stresses and strain. At the end, if you'll find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.